Hey, good afternoon, class. I'm going to do the homework help video for today on the real number system. Okay, real number system. Any and every number is going to be a real number. So every number that you can think of is a real number. Fractions, decimals, whole numbers, integers, all of which are going to be real numbers. Mixed fractions, improper fractions, perfect square roots, non-perfect square roots. Every number you can think of at this moment is going to be a real number, except of course when you get to calculus, you'll learn about other types of numbers, okay? But for now, any and every number is going to be a real number. Real numbers are broken into two different groups, okay? Rational and irrational. Okay, what's the difference between the two? I'm glad you asked. A rational number are numbers that can be written as a fraction, okay? Can be written as a fraction. Let's put numbers that can be written as a fraction, okay? Numbers that can be written as a fraction. Okay, then what are irrational numbers? And remember, at any given time, you can pause and write and all of that stuff. That's the beauty about having a video, right? Irrational numbers, ir is the prefix that means not, okay, are numbers that cannot be written as a fraction. Numbers that cannot be written as a fraction, okay? Numbers that cannot be written as a fraction, all right? There are three types of numbers that cannot be written as a fraction, and then everything else is going to be rational. So let's look at the different types. The first type of number that cannot be written as a fraction is non-terminating decimals. Non-terminating decimals. Those are those decimals that repeat but don't have a pattern as to how they repeat. They go on and on and on and on, but they don't have a pattern as to how they are repeating. Such as, okay, 5.783 dot dot. This is like to be continued. That means this decimal is going to go on and on and on and on and on and on, never stop, but it doesn't have a pattern as to how it repeats. Decimals that have a pattern to how it repeats are rational because you know what number is coming next. It's the ones that don't have a pattern as to how they repeat that are irrational. You cannot write these numbers as a fraction because you don't know what number is coming next. The second kind of number that is going to be irrational, which means you can't write it as a fraction, is pi. You can't just stick a one under it and call it a fraction, a true fraction, okay? Pi is a irrational number because the decimal for pi is 3.14, but it continues, put the dots at the end, it continues without a pattern. You don't know what number is coming next. It doesn't have a pattern as to how it repeats. So this is also an irrational number, not rational. You can't write it as a fraction because it's unpredictable. You don't know what numbers are coming next, and it continues on forever, okay? Without a pattern. The third and last final type of number that is going to be irrational is going to be your your non-perfect square roots. Non-perfect roots, okay? These are your roots that when you simplify them, they're going to have decimals at the end. So numbers such as the square root of 18. The answer to the square root of 18 is going to be a decimal. So if you were to type this in, you're going to get a decimal answer. That's what makes it a non-perfect root. Now, if you're talking about perfect roots, Let's do the square root of 25. The square root of 25 is 5. Why? Because 5 times 5 is equal to 25. This is a perfect square root. It's rational, okay? Because the answer is a whole number. The answer is a whole number or an integer. So that's what makes it perfect. 5 times itself is equal to the number under the radical, which is 25. And this is a radical symbol. This is perfect. This is non-perfect. So this non-perfect square root is going to be irrational. Another one is the square root of 20. It's irrational. The answer is a decimal. If you type it in, you're going to get a decimal. The square root of 3. The square root of 105. All of these are irrational because when you type them in, you're going to get an answer that is a decimal. Okay? If it's not these three things, all the other numbers are going to be rational. So a repeated decimal, if I have 0.7 and it repeats, I know what number's coming next, so it's rational. Fractions, rational. What else? Perfect square root. The square root of, like I said, 25. The square root of 36 is equal to 6. Whole numbers, 7. Mixed fractions, 3 and 1/2. All the rest of the numbers, if it's not in these three categories, are going to be rational. Okay? Even a decimal such as 5.83. Okay, if you don't see those dots at the end, it's rational. Integers. An integer is a whole number and its opposite. Whole numbers, including 0, and their opposites. So positive, negative numbers, and 0. They do not have fractions attached to them. They do not have decimals attached to them. Okay? Make this a little bit clearer. There we go. So that's going to be, I'm starting in the middle, 0, 1, 2, 3, all the way to the positive infinity. Goes on forever, as long as there are no fractions or decimals attached. And then we got -1, -2, -3, all the way to the negative infinity. This goes on forever. Okay, positive numbers, negative numbers, and 0. Whole numbers start at 0. Whole numbers, they start at 0. And they go on to the positive infinity. Okay, so whole numbers are right here. Whole numbers start here: 0, 1, 2, 3, 4, 5, 6, all the way to the positive infinity. So whole numbers start at 0. 1, 2, 3, 4, 5, 6, 7, 8. So they do not have fractions attached to them. They do not have decimals attached to them. It can only be 0 and positive numbers with no fractions or decimals attached. Your natural numbers. Your natural numbers are counting numbers. These are the numbers that you first learn how to count with. Your counting numbers start at 1. When you start counting, you don't start at 0, you start at 1, 2, 3, 4, 5 to the positive infinity. They also do not have fractions attached to these numbers. They do not have decimals attached to these numbers, and they cannot be negative. When you learn how to count, you start at 1, 2, 3, and so on and so forth. And that's your homework, y'all. You got this. Have a good night. Bye.